Welcome to the next lesson. In this lesson, I'll explain the project selection ratios and the significance of the project selection ratios when it comes to really selecting the right projects, which are in true alignment to the organization strategy. The first concept we need to understand here is the time value of money. Whatever I can buy with 1 rupee today, or $1 today, or 1 real today, I will not be able to buy after 1 year or 2 year or 3 years because of inflation, rupee devaluation, etc. Whatever I can buy with 1 rupee today, I will not be able to buy after 1 year or 2 year or 3 years. So when we start a project, when we invest in a project, the money we are investing in a project is today, and the returns we are going to get is in the future. So the money I am investing in a project today is in present value terms. I am investing it today, and the future value is something I'm going to get from the project in the future. So by and large, the sum of the future value or the net cash flows from the project in the future must be higher than the initial investment. Otherwise, the project doesn't have a business case. Again, that is a rough calculation, because whatever I'm investing in the project is in the present value, and the future value is something I'm going to get in the future. So I cannot compare the present value with the future value. Hence, we have formulas like future value is equal to present value into 1 plus r to the power of n, where r is the rate of interest and n is the number of years, etc. Then another concept we need to understand is compounding. Compounding is, okay, let us say I make a investment, I make a deposit in the bank, and I am reinvesting the interest gain on the fixed deposit, so that I can gain interest on the interest as well. So this process, we call it as compounding. And net present value is one of the project selection ratios. What we do is we'll do the cash flow analysis of the project. We know the initial investment, we know the future cash flows, and we convert all the future cash flows into present value terms, and we subtract that from the initial investment. If that is a positive number, the project has a business case. If it is zero, the project is going to be a charity show. But if it is negative, the project doesn't have a business case. Higher the NPV, the better. So if you have 5 projects and if the NPVs are known, net present values are known, we have to always pick up that project whose net present value or the NPV is the highest. Then we have internal rate of return. The rate of return from the project must be equal to or higher than the rate of return the banks would have given me if I had deposited the money in the bank instead of doing the project. We call it as IRR. Again, the higher the IRR of the project, it is the better. Then we have benefit cost ratio. So, yeah, how do we calculate it? Again, we identify all the future cash flows, convert them into present value, and divide the sum of the present value of the future cash flows divided by the initial investment will give us the BCR, or the benefit cost ratio. Again, higher the BCR, the better. So generally, higher the NPV is the better, higher the IRR it is better, higher the BCR it is better. Then again, while choosing the projects, another parameter we need to consider is the payback period. Let us say I put $1 million dollar in a project. Now, in which year I can take out that $1 million dollar from that project? So we call it as the payback period. If it is going to take me 5 years to take the initial investment out of the project, then we say the payback period is 5 years. For metro rails, it is 25 years. So it will take 25 years for the investor to take out the initial investment out of the metro rail project. So these are the basic project selection ratios. We discussed about time value of money. We discussed about present value and the future value. We also mentioned about the formula, that is the future value is equal to present value into 1 plus r to the power of n. We also discussed about compounding, the process of invest money, you put a deposit, you reinvest the interest gained so that we can gain interest on the interest gain and the principal as well. So we call it as compounding. Net present value is sum of the present value of all future cash flows minus initial investment, higher the better. Then internal rate of return, the rate of return from the project must be always higher than the rate of return, the IRR I would have fetched if I had put that money in the bank. Then we have the benefit cost ratio, that is again sum of the present value of all future cash flows divided by initial investment, higher the better again. Time value of money, that is if you have 10,000 today and invested at 10% interest, after 1 year it becomes 10,000 into 1.10, 10 by 100. So that is 11,000. If I invest 10,000 and I reinvest the interest gained, after 1 year I'll get 11,000. So 10,000 today is equal to 11,000 after a year at 10% interest. So 10,000, the present value, is equal to 11,000 future value after at the rate of 10% if I put. Then compounding. Compounding is the process where interest earned also starts earning interest. Formula: F is the future value I'm going to get. So future value is equal to present value into 1 plus r to the power of n. Present value is the money I'm investing today. R is the rate of interest, and n is the number of years we are going to invest. We put it for a fixed deposit. So present value is PV, R is the rate of interest, n is the number of years. So if I put 10,000 at 10% interest for 3 years, future value is equal to present value into 1 plus r to the power of n. So that will be after 3 years, I'll get 13,310 from that investment. So if the project doesn't give me more than this, it is better to put the money in bank and enjoy. Net present value is the difference between the present value of benefits and the present value of costs. NPV is the sum of the present value of future benefits minus the initial investment. So if I'm investing 100,000 in a project, expected returns year 1 40, year 2 50, year 3 30. Then year one, and if I'm putting the R is 10%, then year 1 the corresponding present value would be future value divided by 1 plus r to the power of n. So the present value of the future cash flow 40,000 will be 36,364, which is slightly lower than the 40,000. So present value of 50,000, which I am going to get after 2 years, the present value is only 41,000. So you convert all the future values or the future cash flows into present value. And the total present value of benefits is this much, 1,0226. So NPV is the sum of the present value of all future cash flows. That is 1,0226 minus 1 lakh, that is 226. If NPV is greater than 0, accept the project. NPV is equal to 0, that is neutral, and NPV less than 0, reject the project. But if you have multiple projects whose NPV is greater than 0, then we always go with that project whose NPV is the highest. Then here is an example of IRR. So higher the IRR, better. So accept if IRR is greater than the cost of capital. So if I'm taking a loan from the bank to execute the project at 10% interest, and if the project is going to give me 15% returns, that is IRR is 15, then accept it. But if IRR is only 9, then don't accept that project. Then we have the benefit cost ratio, that is present value of benefits divided by present value of costs, which is nothing but the initial investment we are making. So the BCR is greater than 1, accept. BCR equal to 1, it is neutral. And BCR less than 1, you reject the project. So we discussed about time value of money. We discussed about present value. We discussed about future value, compounding, net present value, internal rate of return, and the benefit cost ratio. Sometimes, youngsters come to me with the great project ideas and they ask my opinion. The first thing I ask them to do is to do a cash flow analysis of the project. So how much investment you're supposed to make? What is the investment required? Year 1, how much you will get? Year 2, how much you will get? Year 3, how much you get means income minus expenditure, net cash flow. And in which year we'll be able to take the returns out of the project, that is the payback period. So this must be done meticulously. Generally, there is a saying like project fail at the beginning, not during execution, not at the end, because project's fate is decided at the beginning itself. If it doesn't have the proper business case, it's very difficult to correct it. So you should never start a project which doesn't have a business case. And sometimes we hear in the charter, there is a section called alternatives analysis. So if you have 4 or 5 project ideas, you may have to do the cash flow analysis, work out the NPV, BZR, payback period, IRR, etc. for all the options we have. And we have to pick up that project whose NPV is the highest. And if there is a tie between two projects, NPV, if there is the same NPV, and which is the highest, then we start looking at the payback period. So if you're a cash-rich company, maybe you can always look for projects where the payback period is higher. But if you're a startup kind of thing where the funds are limited, then we should always look for projects where the payback period is the shortest. Thank you very much.